Hi class, this is Greg. We got to speak about tangible user interfaces recently, and the paper we covered gave an example of a tangible user interface, but I felt that the application that was described fell short of achieving the best possible solution for the problem described. So I started to think about other tangible user interfaces that people work with and that maybe are a little easier and more convenient to solving problems. And I thought of a car. Now, a car has a computer, but except for very recent cars that actually have a touchscreen display, most people don't really communicate directly with the car's computer. And even cars that do have that touchscreen display have a lot of processes that are going on in the background that are initiated by tangible interfaces of pressing shifting gears and pressing pedals and turning the wheel that aren't communicated through the user by the use of that touchscreen. So the first thing I thought of was tire marks that you might see on the road indicating that somebody has slammed on their brakes. Now the photo we have here to the left is kind of a straight, uninterrupted tire skid mark, and this is usually caused by an older car that doesn't have anti-lock brakes, or a car in which the anti-lock brake systems were not engaged. And the photo on the right shows an anti-lock brake system having been engaged. So what has happened is the person has physically slammed on the brakes. That has sent a message to the computer that said, we need to slow this car down really quickly, and the computer has known, because it's been programmed, that the safest way to slow a car down is this rapid compressing and pumping of the brakes. So when the person, just by slamming on the brakes, the computer engages and creates this pumping action, and that's why you see this pattern. Now I have an automatic transmission, which means the gears are shifted by the computer somewhat out of my control. But if I'm, if I'm driving on the highway and I need to speed up really quickly to pass a truck or something, I can intentionally downshift the car by pressing hard on the accelerator. That will drop the car into a lower gear, and I can use that to accelerate quickly and pass another car if needed to. So this is a way I can physically communicate with the computer, either by pressing on the accelerator, or in the case of the anti-lock brakes, pressing hard on the brake pedal to inform the computer of what I want it to do. Now, a lot of modern cars have some great features that are all being controlled by the central computer system. For instance, parking assistance, lane control, monitoring the distance between cars, allowing the driver to maintain a certain speed. And I think the real benefit and the reason why these systems are so helpful is that they are taking an experience which is inherently tangible in the first place, and they're improving that experience. All of these features are controlled by the computer, but they're either initiated or they are resolved by the user taking a physical action of pressing on a pedal or manipulating the steering wheel. What tangible user interface designers should be asking themselves from the beginning is what physical tasks can be improved and what physical actions can generate important data. And when they start from the perspective of the physical action, I think that's where we begin, that's where designers can create interfaces that are really going to be useful, and they're really going to be used in the real world. Thank you very much for watching the video. Hope you guys had a great spring break. See you guys in class.